right, we're going to talk about is lesson 5.2, day 1, basic probability rules. Here are some notes that you probably want to put down for some of these basic rules. The first is probability models, a list showing all possible outcomes and their probabilities. This is where you make a table of all the different type of outcomes and try to determine what is the true probability of an event to occur. When you do this probability model, they must add up to 1. Each probability is between 0 and 1. Those are some key features that you need to make sure that you have when doing a probability model. Also, we want to talk about complements. Besides looking great, which you all are today, joke, all right? The complement really for probability is the probability of an event not happening is really 1 minus the probability of event to happen. So we call a complement a C value. So we say probability of AC, or the complement of A would be 1 minus the probability of A occurring. Now, another term is called mutually exclusive or disjointed. All right, mutually exclusive or disjointed events. All right, we also call this disjointed. Okay, and we have disjointed events or mutually exclusive events that cannot occur together. So they cannot occur together. When we talk about this, we do have this thing called the general addition rule. Whereas when we have P, A, or R, if we want to do P or R, we know that if we don't have any common or there are two mutually exclusive events or disjointed events, that the probability of A plus the probability of B, and we put this OR symbol as this union symbol right here, A or B, is actually that will give you the general addition rule of the two events. Well, let's try this out and check out how to do some problems and check your understanding. So here we go. Explain what is a valid probability model. So if this is a valid probability model, that means that each one of these right here, when we have these M&Ms, and you can read this for yourself, is suppose our team open the corner of a bag of M&Ms, pour out the candies, and observe the colors. According to the Mars, here's the probability model should be composed of this. So for this to be true, 0.07 plus 0.205 plus 0.198 plus 0.135 plus 1.3, oopsies, not 1.3, 0.131 plus 0.124, that would have to equal 1. Each one of these events is between 0 and 1, and add together, this equals 1. So that is why it is a valid probability model. Okay, each event add together equals 1. Explain why events R and blue are mutually exclusive. Well, mutually exclusive, once again, means that can you have an M&M that is red and blue? And the answer is no. All right, so what we know is right here, if we go back, events that cannot occur together. So an M&M cannot be red and blue. All right, cannot be red and blue together. And that's what we know. And so that's why it makes it mutually exclusive. So for each of these, we're going to write using proper notation to find the probability. So to find the probability that you don't get a blue M&M. Well, the probability of not getting a blue M&M, so with probability, we're going to go B being blue, okay? And not getting, okay, so we would have this. Because you don't get a blue M&M, that's the complement, okay? So it'd be 1 minus the probability of getting a blue M&M. And so we would write this as 1 minus, if we go up here, blue is 0.207, and that's what we'd have there. And so we'd have 1 minus 0.207, and we have the probability of that event occurring. We have a 0.793, all right, chance of that occurring. What's the probability that you get an orange or a brown M&M? Because these are mutually exclusive, all right, we're going to find the probability of getting an orange, we'll call it O, or a brown, I'll call it BR, all right, BR, all right, event. So What's the probability of getting an orange one? What's the probability of getting a brown one? If we would add those together, because they're mutually exclusive, we can go up here, all right, an orange. So we would take 0.205 plus our brown, which is 0.124. You would take those two values, bring them down here, shoop, and add those together. And so we have 0.205 plus 0.124. And so we would have this as our answer, 0.329. Okay. And then finally, what is the probability what's the probability that don't get a red or a green? All right. So we don't get a red or a green. Okay. So essentially, we're getting the probability where we won't get a red, and I'll call that R. All right. So we don't get a red or, all right, or a green. I'll call that G. And I don't think there's any other G's in there. Nope. All right. So we have G, and we don't get that. And so essentially, we're taking the complement of those two. So two different ways of doing this. We could take 1 minus the probability, all right, of getting a red. Okay. And we could add that to, all right, and then we want to add this together. All right, we would add that to 1 minus the probability of getting a green. We add those two together, and that's what we'd have, because those are probability that we don't get a red or green. We could also add, all right, blue, all right, orange, yellow, and brown. We could just also add all those four values together as well. Well, in any case, if we want to figure this out, okay, two different ways of doing this very similar thing. We could also take this value. Let me just erase this. We could also take this right here, is because if we want to find this value, and I think I may did that one wrong, minus, all right, the probability, or we could just add those together, the probability of getting a red, all right, and the probability of getting a green, and subtract that probability from 1. All right, and so that's what we can do right here. So if we had this 0.198 and 0.131, all right, so these two together, subtract that from 1, all right, you would get a probability of 0.671. All right, and that is what we know there. Okay, so essentially what we have is that is the probabilities that we would have for doing those two. The one that I just wrote down right here, 1 minus the probability of R, all right, plus 1 minus the probability of G, that would not be correct. And if you check this one out, I made an error. My error is when I add these two together, all right, we'll have 2 minus these two probabilities, all right, which would then be not larger and would create a value that's larger than 1, which would be incorrect, and that would not be a proper way of doing it. So I apologize for even bringing that up. So I was in denial or not correct. This would be the correct way of proceeding with that. So be careful and don't be like me. All right, and so that's what we'd have. All right, well, I hope that helps you out. And doing some probability rules, we're going to do another example in the next video. All right, good luck and God bless.